Hello everyone, this is Miss Chelsea and today we'll be learning about scatter plots. Now, a scatter plot is a graph that displays data for two sets of variables. Two pieces of data variables being compared at the same time is called bivariate data. If of those two pieces of data, as one variable increases, the other increases as well, we say that this is a positive association. If as one variable increases, the other decreases, on the other hand, we call this a negative association. If a line can be reasonably drawn through the points of the graph and the majority of the points follow that line closely, we call it a linear association. If we cannot draw a line through the data points because the points would not stay close to the line, we call that a nonlinear association. When data points in scatter plots form distinct groups, so they're all clumped together, we call that clustering. The data that does not fit the general pattern of the majority of data is called an outlier. Now that we know what the terminology means, let's try identifying components of a scatter plot. In example 1, the scatter plot below shows data comparison of the age of a child and the cost of a birthday gift for that child. Notice how as the age of the child increases, the price of the birthday gift also increases? This means we have a positive association. Since you could draw a straight line through the data and the points fit it reasonably well, this is a linear association. There are actually 3 points that do not fit the general trend of the data. This point, and this point. These are our outliers. There are no particular clusters of data that stand out in this problem. Now let's try example 2. The scatter plot below shows data comparison of energy levels of people and the time that has passed since drinking a cup of coffee. Notice how as the time increases, the energy level decreases. This is called a negative association. The data here fits a curve a lot better than a line, so this is a nonlinear association. Notice how this piece of data and this piece of data do not fit the general trend. They are the outliers. Finally, notice how there's a big clump of data right here in the middle of your graph. This is called clustering. Now, pause the video and use what you've learned to try the practice problems below. For number 1, you should have checked that it has a negative linear association. For number 2, you should have checked that there is neither a positive nor a negative association, making it nonlinear. For number 3, you should have checked that there was a positive and nonlinear association. For number 4, you should have checked positive and linear. For number 5, you should have checked negative and nonlinear. For number 6, you should have checked positive and linear. Number 7 is negative and nonlinear. And number 8 is positive and nonlinear. Next, we are going to construct a scatter plot based on the data gathered from our poll of the class. Is there a relationship between how many siblings someone has and how many chores they are required to do at home? For the purposes of the video, I will be making up the data. However, in class, we are going to use the actual data we collect. We need to identify the range of our data and label our axes accordingly. Well, for siblings, we go from 0 to 7. That means we want at least 7 as our maximum number. I'm just going to count by ones, make it easy. And for chores, we need to go from 1 to 6. So chores only needs to go to 6. Once again, I'm just going to make it easy and count by ones. Now we need to plot our data. There are 2 people with 0 siblings, and each of those has a different number of chores. One only does 1 chore, and the other one does 6 chores. Of people with only 1 sibling, one of them only does 1 chore, and the other one does 3. For 2 siblings, we have 3 and 4. 3 siblings gives you 6, 4, and 5. 4 siblings doesn't exist. 5 siblings doesn't exist. 6 siblings doesn't exist. But there's one person with 7 siblings who only does 2 chores. Notice how as the number of siblings goes up, the number of chores also goes up if you ignore the outliers. Well, that means we have a positive association. And if you look, it actually does fit a straight line pretty well. So I'm going to say we have a positive linear association with 2 possible outliers. Now that we've learned how to construct scatter plots and interpret their data, I'd like you to try the practice. Don't forget to check out Mo Money, Mo Problems as well.